For 5.3, we're going to be looking at adding and subtracting radicals. So again, some information you're going to need before you start is how to add or subtract them. So to add or subtract radicals, there's two things that you've got to have that need to be the same. The first is the index. So you've got to make sure that if you've got a cube that you're adding to something else, then it also has to be added to a cube. Or if you've got a square root, you're going to be adding it to a square root. Then the second part is the radicands also have to be the same. So in order to be able to add two radicals, you have to have both the index and the radicand. Neither of them is going to change though. What's going to change is basically the coefficient. So if you have 3 cubed root of x plus 2 cubed root of x, that's going to become 5 cubed root of x. In problem 1a, we're given what is the simplified form of 3 square root of 5x minus 2 square root of 5x. So the first thing that we've got to check is to see, do we have the same indexes and do we have the same radicands? So both of our indexes are 2, and then both of our radicands are 5x. This means that we can go ahead and subtract the coefficients, and we're left with 1 square root of 5x or just square root of 5x. In problem 1b, we're given what is the simplified form of 6x squared square root of 7 plus 4x square root of 5. So when we check this, we look and see that we've got a square root and we've got a square root, so we're good there. But the radicand on the first one is 7 and the radicand on the second one is 5. So there's absolutely nothing we can do with this. So the correct solution is just to rewrite the original problem. 6x squared square root of 7 plus 4x square root of 5. For 1c, we're asked what is the simplified form of 12 cubed root of 7xy minus 8 fifth root of 7xy. So again, what we're going to do is we're going to check these indices, and we've got a 3 on the first one and a 5 on the second one. You can go ahead and stop there because there's nothing that you can do with these. The answer is just going to be rewriting the original problem, which was 12 cubed root of 7xy minus 8 fifth root of 7xy. In problem number 2, we're given a word problem. In the stained glass window design, the side of each small square is 5 inches. Find the perimeter of the window and then leave your answer in radical form if necessary. So you can see that the perimeter of the window is actually the diagonal of the squares. So what we've got to do is we've got to find the length of the diagonal of the square before we can do any sort of solving. Now, what you should remember from geometry is that if you have a square, then the sides of the square, if we use the diagonal, or if we cut a diagonal through the square and create 2 right triangles, we're going to have the ratio a square root of 2, where a square root of 2 is the diagonal. So what we know is that the side is 5, so a is 5, and that means that we've got a diagonal of 5 square root of 2. The other way you could have gotten this was to use Pythagorean theorem. So what we know is you can count up the number of diagonals that we've got. You've got the 2 purple triangles at the top. You've got a green, a purple, and green along the side, a purple and a purple along the bottom, and then a green, purple, and green along the other side. So there are 10 total triangles. So there are 10 lengths of 5 square root of 2. So 10 times 5 is 50. 50 square root of 2 inches is going to be the solution. For problem number 3, we need to simplify before we can add or subtract. So we're asked, what is the simplest form of the expression square root of 12 plus square root of 75 minus square root of 3? So if we were just to look at these and say, can we add or subtract these? No, we wouldn't be able to, because even though we do have the same indices, we've got different radicands. But let's take a look at the radicands and see if we can't simplify them. So what is the biggest perfect square factor that goes into 12? Well, we get 4. So we get 4 times 3. For 75, we get 25 times 3. And then for square root of 3, we've already got it simplified. So then take square root of 4 times 3. We take the square root of 4, that gets pulled out to 2 square root of 3. 25 times 3, we take the square root of 25 and we get 5, so it becomes 5 square root of 3. And then we've got minus square root of 3. So now we've got a new line of 2 square root of 3 plus 5 square root of 3 minus square root of 3. In this case, all of our indices are the same and our radicands are also the same. So now we can add or subtract these. So 2 plus 5 is 7, minus 1 is 6, so we get 6 square root of 3. The next thing that we need to know or that we need to review is FOIL. And in some countries this might be called open. But what we're going to do is first outside, inside, last. We're going to multiply or distribute each term against the other terms in the other quantity. So we do x times x first, and then we do x times the negative y, and then we do y times x, and then we do y times negative y. So first, the first terms of each, then the outside terms of each quantity, then the inside terms of each quantity, and then the last terms of each quantity. For problem number 4a, we're going to go ahead and multiply binomials. So we're given 4 plus 2 square root of 2 times 5 plus 4 square root of 2. So let's employ FOIL or the open method. So the first is 4 times 5, which gives us 20. 4 times 4 square root of 2, which is 16 square root of 2. 2 square root of 2 times 5, which is 10 square root of 2. And then 2 square root of 2 times 4 square root of 2. Again, what we're going to do is we're going to multiply the coefficients and then multiply the radicands. So we get 8 square root of 4. Now let's go ahead and simplify that last term down to 8 times 2. And then we're going to go ahead and start simplifying everything at this point. So bring down, we'll end up with 20 plus 16 square root of 2 plus 10 square root of 2 plus 16. And then combine like terms, 36 plus 26 square root of 2. The next problem gives us 3 minus square root of 7 times 5 plus square root of 7. So again, use the FOIL method or the open method. So 3 times 5 is 15. 3 times square root of 7 is 3 square root of 7. Negative square root of 7 times 5 is negative 5 square root of 7. And then negative square root of 7 times positive square root of 7 is negative square root of 49. Negative square root of 49 simplifies down to negative 7. Combine like terms, 15 minus 7 is 8. And 3 square root of 7 minus 5 square root of 7 is negative 2 square root of 7. For problem number 5, we get a pair of conjugates. So since we've got conjugates, we don't have to worry about the O and the I in FOIL. So we're just going to multiply the first and the last. So 5 times 5 is 25. Negative square root of 7 times positive square root of 7 is negative square root of 49. That simplifies down to 25 minus 7, which gives us 18. Finally, we're going to look at rationalizing a denominator using conjugates. So we've got what is the simplest form of each expression? 3 square root of 2 over square root of 5 minus square root of 2. So what we're looking at is the denominator. We've got to get rid of those square roots. So the way that we're going to do that is to multiply by the conjugate. The conjugate of square root of 5 minus square root of 2 is square root of 5 plus square root of 2. So across the top in the numerator, we're going to distribute. So 3 square root of 2 times square root of 5 and 3 square root of 2 times square root of 2 is going to leave us with 3 square root of 10 plus 3 square root of 4. Then in the denominator, we've got square root of 5 minus square root of 2 times square root of 5 plus square root of 2. Remember, since we're using conjugates here, we don't have to worry about the O and the I. All we have to worry about is the F and the L. So square root of 5 times square root of 5 is the square root of 25. And then negative square root of 2 times positive square root of 2 is negative square root of 4. So simplify any perfect squares or any radicands that we can simplify. And we get down to 3 square root of 10 plus 3 times 2, because the square root of 4 is 2. Square root of 25 is 5. Square root of 4 is 2. So we're left with 5 minus 2 in the denominator. 3 square root of 10 plus 3 times 2 gives us 6 plus 3 square root of 10. 5 minus 2 is 3. And then what we can do, remember that we can think of this as two separate fractions. We can write it as a single fraction, which it is on here, 6 plus 3 squared root of 10 over 3, or we can write it as two separate fractions, which would be 6 over 3 plus 3 squared root of 10 over 3. That tells us that we can cancel out, or we can reduce anything in the numerator with that denominator. So 6 divided by 3 is 2, 3 divided by 3 is 1, so we're left with 2 plus the square root of 10.